Hey physics students, today I'm planning on teaching a little bit about projectile motion. And so this is basically any type of two-dimensional motion that has both a horizontal and a vertical component. If you had a kickoff in a football game, if you throw a baseball, a bullet traveling through the air, or a cannon shooting across a battlefield, any of those could be projectile motion. They are more complex than what we spent studying the first semester. In the first semester, we were only focused on one dimensional. So something moves and it travels straight across, or it goes straight up or straight down. Now we're combining horizontal and vertical motion. The big idea in this is that the horizontal motion will always be simplified down to constant velocity because we ignore air resistance. So as something travels horizontally, it will always have the same horizontal velocity. The vertical motion, however, will have a constant acceleration. The constant acceleration for the vertical part is based on gravity, and we're going to use the acceleration of gravity to be negative 10 meters per second squared. Okay, going back as a review of ideas in constant acceleration and constant velocity, anytime you have a position time graph, the slope of that graph will equal your velocity. Anytime we look at a velocity time graph, the slope of that will be the acceleration. If you look at the velocity time graph, the area under the curve will show you the displacement or the change in position. And anytime you look at an acceleration time graph, the area in that will be equal to the change in velocity. Those are just some of the ideas that we talked about in the first semester. Okay. As we look at projectile motions, we can classify all of them into three major categories. The first category would be a drop problem. Now I'm going to look and show you a little picture here of a board. On the board we have, this is not a velocity time graph or a position time graph. This is position versus position. So it's vertically what's going on and horizontally. Okay. Down here I have a velocity vector for something that's being launched. You can have the actual velocity, and it breaks up into the vertical part, Vy, and the horizontal part, which is Vx. If that Vy is 0, then we only have Vx. And if Vx is the exact same as the initial problem, then this would be considered a drop problem. A drop problem will always look like this, a parabola that goes down. Or if it's going faster, it might do something like that. But no matter what, any drop problem will always look like that. If, however, we have an initial velocity that's negative, I would call that a throwdown problem. A throwdown problem looks similar, except it would be kind of like this. Negative initial vertical velocity, horizontal velocity is the same. It would look like a parabola, but it's not flat at the top. Okay, so it's going to be going down much further. I don't really like those problems, so we won't be dealing with those too much. Okay, going back looking at the notes. So drop problems, an example of a drop problem would be if a ball rolls off a table, or if you are standing on a cliff and you throw a stick out horizontally off of that or off of a bridge. Or if you're standing in a tree stand and you shoot a gun straight outwards, that is going to be considered a drop. It doesn't have any initial angle. The initial angle is 0. A throwdown problem is going to be different. That's going to be something that has an initial negative velocity because you're shooting it downwards or throwing something downwards. Okay, so the first two ways to classify problems are drop or throwdown. The next type is throw-up problems. And there's actually three different ways to describe those. We have throw-up A problems, throw-up B, and throw-up C. A throw-up A problem is going to be a problem that starts and ends at the exact same height. So if you kick a football, it's going to go up and it's going to come back down. that would be considered a throw up A problem. It starts at one height and ends at another height. Okay, a soccer kick, corner kick in soccer, that's going to start off, as long as it doesn't hit anything, as a throw up A problem. Okay, and I call it throw up because it has an initial vertical velocity. Okay, the next type of throw up problem would be a throw up B problem. I picture that as something like shooting a basketball. If you start at a lower height and you end at a higher height, that's going to be a throw up B problem. Throw up B starts low, ends high. Throw up A starts and ends at the same height, and then throw up C would be the other version, where you start off up high, you throw something, and then it falls farther than it went up. So you throw it up and it goes farther down. So if you're standing on top of your roof and you throw a basketball up in the air away from your house, it's going to start up and it's going to go down. So that would be considered a throw up C problem. Okay, and then we have, so the examples, like we said, a kickoff in football, that would be throw up A. A basketball free throw would be an example of a throw up B. And that last one is not edited yet. So this last one would be starting and ending at a different height. Okay, I went ahead and I pulled up some Dude Perfect videos. I got the ping pong trick shots number 4. And I want to show you a couple of examples from that show examples of different throw-up problems. Okay, so this very first one, the guy starts and he throws the ping pong ball and it goes about the same height. So that right there, he throws it, it's mostly about the same height that it starts and ends. Okay, that's throw up A. Throw up B problem, that's when you start at one height and it goes and it ends at a higher height. So on that one, the ball started lower and it ended at a higher spot. So he throws it from his hand and it's lower than the plane and it ends up in the top of the plane. So that would be throw up B. A throw up C shot is where it starts up high and it ends down low. So this is an example of a throw up C. Okay, so that would be a throw up C. Your homework, one of the things that you're going to do is you're going to go through and you're going to pick a projectile or one of these Dude Perfect trick shot things, and you're going to go through and you're going to classify a bunch of different shots. If you look at my slides here, I tell you the type of shot. So the second shot after the first bounce at 2 minutes and 18 seconds, that would be an example of a throw up A. The double splash shot, the first shot he shoots at 3:26, and the catapult shot at 4:15. All of those are examples of throw up A. And then the same thing, I got a bunch for throw up B and throw up C. I want you guys to watch one of those videos. You can pick either ping pong 1, 2, 3, or 5. Not number 4 because I did that one. But you can go through and I want you to tell me what the shot is, when it is, and tell me, is it a throw up A, B, or C? There's a chance that you might also find a drop or a throwdown problem. So if you find any of those, go through and classify those and then turn that in. Also make sure that you've filled out the attendance sheet and that you've asked the physics question. We're going to go, this was an introduction to projectile motion. Again, projectile motion, the big idea is that your horizontal motion is constant velocity and your vertical motion is a constant acceleration. Hope you guys have a good day. If you can make it to the Zoom calls, go ahead and let me know or show up. And if you have any questions, make sure that you email me. Have a good day, guys.